Hello guys, in this lesson we are going to cover how we select our regionalized variables. So there are two conditions that we need to needs to be satisfied for one to be able to apply any geostatistical method. So these are more like your preliminaries. If you want to check that whether you can be able to apply the techniques that we are going to cover in this course, you need these two conditions to be satisfied. The first condition is called data homogeneity. Data homogeneity reflects that the data should have one parameter. It should be measured by the same measurement or instrument, and then the measurements should be made on the same volume. I think that's clear. Number two, it's additivity or closure under addition or closed under addition. So the parameter should have the property that 1 over n of the summation of I to n of ZUI has the same meaning as ZU. So this is more like the mean should have the same meaning as U. So in mathematics, what we call a closure under an operation. So if performing that operation on the members of the set always produce a member of a set. For example, if you have got a 2 which is an integer and then you have got a 4 which is an integer, perform an addition operation between these two, I get a 6. And what is a 6? It is an integer. So this is additivity. So it is addition can be applied in this sense. Maybe another example, two dogs plus 2 dogs, I get 4 dogs. So adding dogs, I should get a dog. Alright, so let's move on to the example. So suppose that ZU represents the thickness of a layer measured in meters. If the average thickness over a certain area is needed, so then the arithmetic mean of the regular sampling is a good estimator for this. But if instead we use a cube of that number, for example, Z prime U is equals to ZU cubed for the thickness, then the arithmetic mean of this individual Z prime UI value is not the cube of the mean thickness. To see this, let's consider ZU1 to be equals to 1 and ZU2 to be equals to 2. So Z prime U1, so we cube this will give you 1 times 1 times 1, 1, and then we apply a cube there. This will be 2 times 2 times 2, which gives us 8. Then the mean we have, for the mean, then we have, so the mean we have got for the first one, this one, if you add the mean, then you have got 1.5. And then for the cubed one, if you add the mean, then you have got 4.5. As you can see, there is much difference between the thicknesses estimated by those. So therefore the assumption of additivity does not hold for the cube. So by definition, a cubed there is given by this. Therefore a mean cubed for this one will be 1.5 cubed, which is different from 4.5. So if I cubed this value, it does not give me this one. So additivity on cubed is not, it does not hold, hence can't add those on cubed. A more silly example would be like if you have got 2 different cubes and then you want to add them and then consider the thickness, and then so adding this maybe might mean attaching this on one of the surfaces of this other cubed. So this is not equals to a cubed. So if you attach that, the small cubed on top of this one, this will not give you a cube. So adding 2 cubes should give you a cube, but in this case it does not give you a cube. Okay, so thank you, and then make sure you attempt the following questions.